You think you know networking? This isn't a quiz for memorizing commands, but it's a test of real, practical networking knowledge used in cybersecurity and enterprise environments. Answer these 12 expert-level questions in your head, then listen to the explanation. If you get more than 10 right, you're operating at a pro level. Ready? I'll read the question, give you 10 seconds to think, then reveal the answer and a short explanation. No tools, no how-to, just advanced concepts you must understand. Question 1. What is the main purpose of BGP's AS path attribute in route selection? Think now. Answer. The AS path records the sequence of autonomous systems a route has traversed and is used to prefer shorter AS paths. Explanation. AS path helps prevent routing loops and is a primary metric in BGP path selection. Shorter AS paths are generally preferred because they imply fewer networks between source and destination, though operators can influence selection with policies and local preferences. Question 2. In TCP, what does the SYN, ACK, FIN sequence represent at a high level? Think now. Answer. SYN initiates a connection, ACK acknowledges receipt, and FIN gracefully closes the connection. Explanation. The three-way handshake, SYN, AKI, ACK, establishes session state between endpoints. FIN signals intent to close the session. Understanding this state machine is crucial for detecting abnormal or malicious connection behavior. Question 3. What is ARP spoofing conceptually and why is it effective on switched networks? Think now. Answer. ARP spoofing forges. ARP replies to associate an attacker's MAC with another host's IP, enabling interception or redirection of local traffic. Explanation. On flat L2 segments, switches forward frames based on MAC tables. If ARP cache entries are poisoned, traffic intended for a victim can be redirected through the attacker's machine, enabling MITM or traffic capture. Question 4. What is VLAN hopping and what architectural mistake allows it? Think now. Answer. VLAN hopping is when an attacker gains access to traffic on a VLAN they shouldn't see, typically due to misconfigured trunking or native VLAN use. Explanation. If switch ports or trunks are improperly configured, e.g. native VLAN left default, unnecessary trunk ports exposed, attackers can craft frames that cause a switch to forward traffic across VLAN boundaries. Proper port configuration and VLAN segregation mitigate the risk. Question 5. What does MPLS do in a service provider network at a conceptual level? Think now. Answer. MPLS forwards packets based on short fixed-length labels rather than full IP routing, enabling fast, policy-driven forwarding and traffic engineering. Explanation. Labels let providers create LSPs, label-switched paths, for predictable paths, QoS, and VPN services. It separates forwarding from routing decisions and improves scalability and performance in large backbones. Question 6. Explain the difference between stateful and stateless firewalls conceptually. Think now. Answer. Stateful firewalls track connection state and make decisions based on session context. Stateless firewalls inspect each packet independently using fixed rules. Explanation. Stateful inspection allows richer security decisions, e.g., allow return traffic only if session exists, while stateless is faster, but cannot correlate packets into flows. This difference affects how each handles asymmetric routing and session-based attacks. Question 7. What is the role of a root reflector in ibgp deployments? Think now. Answer: a root reflector reduces full mesh ibgp requirements by reflecting routes between ibgp peers, avoiding the need for every router to peer with every other. Explanation: ibgp normally requires full mesh connectivity. Reflectors allow scalable architectures by receiving routes and selectively advertising them, though careful policy is needed to avoid suboptimal routing. Question 8. What is the significance of TCP window size in high latency networks? Think now. Answer: TCP window size determines how much unacknowledged data can be in flight. In high latency links, a larger window is required to fully utilize bandwidth. Explanation: bandwidth delay product dictates optimal window sizing. If the window is too small relative to RTT and link capacity, throughput is limited regardless of link speed. Question 9. What is an ACL, access control list, and how does order affect its behavior? Think now. Answer: an ACL is an ordered set of rules permitting or denying traffic. Evaluation is sequential and the first match determines the action. Explanation: because ACLs are processed top to bottom, rule placement matters. A broad deny near the top can block legitimate specific allow rules below. Proper ordering and explicit defaults are critical. Question 10. Conceptually, how does NAT affect end-to-end connectivity and why is that important for some applications? Think now. Answer: NAT rewrites IP addresses, GEO ports, breaking true end-to-end addressing and complicating protocols that embed IP information or expect direct connectivity. Explanation: NAT provides address conservation and a layer of indirection, but services like VoIP, peer-to-peer, and some VPNs require NAT traversal techniques because the public-private mapping obscures original endpoints. Question 11. What is DNS cache poisoning at a high level and why is DNSSEC relevant? Think now. Answer: DNS cache poisoning injects false DNS responses into resolvers, redirecting users to malicious IPs. DNSSEC adds cryptographic signatures to verify authenticity. Explanation: poisoned responses can persist in resolver caches and affect many clients. DNSSEC helps validate that DNS data hasn't been tampered with, reducing risk of redirection and phishing. Question 12. What is the purpose of network segmentation and microsegmentation in security architecture? Think now. Answer: segmentation limits lateral movement by isolating network zones. Microsegmentation applies that principle at finer granularity, per workload or app, to contain breaches. Explanation: by dividing networks into trust zones and enforcing controls between them, an attacker who compromises one segment cannot freely access others. Microsegmentation strengthens zero-trust postures in virtualized cloud environments. How many did you get right? 0 to 4 means you needs work. 5 to 8 equals solid pro basics. 9 to 10 means you're an advanced engineer. 11 to 12 means you're a top-tier network practitioner. Drop your score in the comments and tell us which question you want a deep dive on. This video tests knowledge only and does not provide instructions for illegal activity. All explanations are conceptual and intended for defensive and educational purposes. If this challenged you, like and subscribe to Hack Only Evil for more expert-level quizzes, cybersecurity explainers, and real-world networking breakdowns.